So we are going to talk more about our unit circle today. Before we get into our unit circle, I want to refresh. Remember this x, y, and r definition we had previously. What was the definition of sine? Opposite over hypotenuse when we were talking about a triangle. What about when we did x, y, and r? What did we say? Yes. So that means cosecant was r over y. What's the definition of cosine?
X over R.
So that means secant is r over x. Tangent?
Y over X.
So that means cotangent is
X.
x over r. All right. Now let's talk about the unit circle for a moment. The unit circle, we said, is a circle centered at 0, 0 with a radius of 1. So this was the magical 0, 0. We have our x and y axis. The radius is 1. If the radius is 1, that means for any point on the circle, sine is y over 1, which is just y. That means cosine is x over 1. I should say on the unit circle, not just any circle. So the cosine is the x. Cosecant is still the reciprocal. And tangent, cotangent wouldn't change. So, if I am talking about any point on the circle, we can add ordered pairs. I want you to write at the top, the x is cosine, the y is sine. So when we do ordered pairs, it's cosine theta, sine theta. And I'm going to fill in the degrees and radians that you already have on that big circle from last time. So remember, the first quadrant was our hand trick angles. Jump down to 180, then we subtract our reference angle. 150, 135, 120. We add our reference angles, so 210, 225, 240, 270. Then we subtracted from 360 here, so 330, 315. 300, so those were the degree measures. For the radians, we said 0 degrees was 0 radians, 30 was pi over 6, 45 pi over 4, 60 pi over 3, 90 pi over 2. Remember, we talked a lot about the reference angles. So everything 30 degrees from the x-axis, those all have the same reference angle. These are everything that's 45 degrees away. And everything that's 60 away. And remember, when we were listing our radians, the only thing that changed was the numerator. So everything with the same reference angle had the same denominator. So over here, my denominator is 6, but in the second quadrant, the top was 1 less. So 5 pi over 6, 3 pi over 4, 2 pi over 3. And this is pi. Third quadrant was 1 more, so 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2. And here, it's double minus 1. So 11 pi over 6, 7 pi over 4, 5 pi over 3. All right, so we're okay with that. That's what we've done in the past. I want to add ordered pairs now. Now, we're going to do the first few just by thinking about it. We know this is the point 0, 0 in the middle. And my radius is 1. So what is this point on the circle? What would this point be on my unit circle? Okay, this ordered pair would be,
Negative.
and this one,
0, negative
if I'm trying to fill in more of these things, okay, we have an infinite number of points on the circle. You know, I could get an ordered pair anywhere. We're only focusing on the nice ones, the ones we're worried about. If I'm here and I'm moving up the circle, we can see our x's should be getting smaller, right? Because x is getting closer to 0, and my y's should be getting bigger. It's the first quadrant, so everything's positive. Right, think about our hand trick. When we say 0 degrees, on our ordered pairs, the cosine is x. The cosine of 0, radical 4 over 2, is 1. Sine of 0, radical 0 over 2, is 0. Go to 30. Look at your hand trick. Cosine comes first. What's the cosine of 30 degrees? Radical 3 over 2. The sine of 30 degrees, I have one finger above, so radical 1 over 2, or 1/2. If I go to 45, cosine is the bottom. I have two fingers below, so radical 2 over 2. Sine is the top. I have two fingers above, so radical 2 over 2. 60 degrees, sine is the bottom. Radical 1 over 2, or 1/2. Cosine is the top. Sorry, I said it. Sine is the top. Radical 3 over 2. So look, did my x's get smaller and my y's get bigger? Yeah. Now, we could go through and keep figuring these out, but actually we don't need to. When they have the same reference angle, they're going to have the same ordered pair. So all these yellow lines have the same ordered pair, radical 3 over 2, 1/2. We just have to think about the quadrant for a moment. If you're plotting a point over here, what's true about the x value?
It's negative.
Yes, so this would be negative radical 3 over 2, 1/2. At 3 pi over 4, it'll be the same as pi over 4, except x is negative. So negative radical 2 over 2. Radical 2 over 2. 2 pi over 3, the same as pi over 3, but x is negative, so negative 1/2. Radical 3 over 2. All right, if you're plotting a point in the third quadrant, what's true about it? X and y, same angles, so match up. 7 pi over 6 and the pi over 6 go together. Just both negative, so negative radical 3 over 2, negative 1/2. Pi over 4 is the same as 5 pi over 4, just we need both negative. Negative radical 2 over 2, negative radical 2 over 2. 4 pi over 3 and pi over 3. Negative 1/2, negative radical 3 over 2.
I don't got book today either.
Ooh, it's going to be a good day. Maybe you'll have time to get that assignment you're missing.
I do not think we'll have something. I promised like 2 weeks ago that I would today. Because I've been so busy.
All right, what about in the fourth quadrant? Yes, so pi over 6 goes with 11 pi over 6, but with the y is negative, so radical 3 over 2, negative 1/2. 7 pi over 4 would be radical 2 over 2, negative radical 2 over 2. 5 pi over 3 would be 1/2, negative radical 3 over 2.
Only it was
Hmm.
I said if only it was applied.
Ah, that would be amazing. Telling you, it's these short weeks that seem so long. Every time. All right. So here is that unit circle and everything I can put on the unit circle. It looks like a ton of information, but hopefully you're recognizing it's actually not that much stuff. It's the same thing over and over again. All these ordered pairs, you just have to watch your quadrant to know which things are positive or negative. And then you just have to match them up to their reference angle. Any questions about that? So I might at some point do a quiz over this. Should be easy quiz points. We'll practice it before then. I probably would not require one of these on the test because it's not anything new. I'm just giving you another tool for the same things that we've been doing. So if I ask you for the sine of 7 pi over 6, you could look here, here's 7 pi over 6, sine is the y, it's negative 1/2. Obviously, that's real helpful if you have a filled out circle in front of you, but on the test, I wouldn't give you one filled out, right? I will have blank ones available on any test or quiz, so if it helps you, you're welcome to grab one and fill it in, but I probably won't require it because we can already evaluate these things by doing quadrants and reference angles. So we might do a quiz just to practice it and make sure you can, but test time, I would expect you to only do it if it helped you. Does that make sense? So today, we now have this circle, so we could certainly quickly answer our questions just by copying values off the circle, but I really want to use this as a tool, not the only way to figure it out. So I want to continue trying to solve the problems as we have in the past, and then use this to check ourselves and make sure that we are correct. So let's say I asked you this question. I want the exact value for each of these angles. These are questions that we have been solving for a long time. They were on the last test. We just had them in degree form. We've had them on our homework. When we evaluated them, we asked ourselves questions like quadrants and reference angles. Now, 3 pi over 2 is probably not the nicest one. Does it really exist in a quadrant? No. So you could think about it in terms of the hand trick if you think about 90 degrees as a reference angle. Okay, so if I think about 90, sine of 90, so the square root of the top over 2, radical 4 over 2 is 1, but since it's 3 pi over 2, it would have to be negative 1. Cosine, square root of the bottom over 2, so square root of 0 over 2 is 0. Tangent, square root of the top over square root of the bottom. So radical 4 over radical 0 is undefined. But you also have a circle that you could use to help you evaluate that. So take a look at your unit circle. Sine is the y. So we find 3 pi over 2, our y value was negative 1. Cosine is the x, our x was 0. Tangent, y over x, negative 1 over 0 is undefined. So we can get it using old techniques or the circle. Okay? Let's look at another one. If I ask you to find these, so on this one, you would have to do quadrants and reference angles. So what quadrant is 7 pi over 4 in? Quadrant 4, double minus 1. Reference angle. In radians, it's easy. It's just pi over the denominator. You might need to think in your head, pi over 4 is like what degree? In quadrant 4, all students take calculus. Cosine is positive, so that means sine will be a negative. Okay, if I go to my 45 degrees, sine, square root of the top over 2, so negative radical 2 over 2. Cosine, square root of the bottom over 2, radical 2 over 2. If you look at your unit circle, 7 pi over 4, cosine is radical 2 over 2, sine is negative radical 2 over 2. So it's just another tool to help us. Is that okay? What would you do if you had a negative angle? It would either spin backwards 5 pi over 3, or if you preferred, you could add 2 pi. Why don't you guys try these two? So we get the tangent of pi over 3, which is just like tangent of 60. Go to your hand trick, it's radical 3. If you're trying to use your unit circle at pi over 3, tangent is y over x. So if you flip and multiply, you also get radical 3. 2 pi over 3, what quadrant is that?
2.
Reference angle is pi over 3, or you can think 60 degrees if you need to. So in quadrant 2, sine is positive, so that means cosine is negative. Cosine of 60, square root of the bottom over 2, so negative 1/2. Or if you look at your unit circle, 2 pi over 3, cosine is the x, negative 1/2. Please, I'm going to give you guys plenty of time in class to work on homework, so please don't just copy them off the circle. Think about them, check yourself on the circle. All right, any issues with this type of problem? We have done calculator problems before, so we can continue to solve things on our calculators now. The only thing I want you to watch, the last time we had these, like in our last chapter, they were always in degrees, and I would say over and over again, every time you picked up a calculator, make sure it's in degree mode. Are these in degrees? No, so what mode should we put our calculator in? Needs to be in radian mode. So first pick up your calculator, put it in radian mode. All right, then we can just type this in, cosine 1.85. And we get negative 0.2756. Right? If I ask for cotangent, how do we get cotangent?
1 divided by 2.
Scratch out there, 1 divided by tangent, 1.3209. We get 0.2552. Right, how would we do secant?
1 divided by sine. Cos. A little bit back and forth.
Secant's the reciprocal of cosine. And we get negative 1.024. All right. So far, so good. I have 2 more slides. So if I asked you to find s in the interval 0 to pi over 2, this tells me 2 things. First of all, pi over 2 is in radians, so it tells me make sure you're answering in radians. It also tells me the quadrant. If we're between 0 and pi over 2, that's quadrant 1. Now, I don't know when cosine is equal to this, so I'm using my calculator. Your calculator will automatically give you the answer in quadrant 1, so we don't have to do anything special. How did we find a missing angle? What did we have to plug in? Remember, anytime we wanted to find the angle, we had to move the cosine to the other side, which is when you did cosine inverse. Since I want an answer in radians, we just make sure we're in radian mode, which we are, so that's when we do second cosine. and we get 0.2517. So I'm asking something very similar, except this is one I don't need my calculator for, because I know when tangent is 1. So if it's one of the common angles, I don't want you to use your calculator. We are in radians. If I am between pi and 3 pi over 2, what quadrant are we in? 3. Reference angle. When is tangent equal to 1? So think about your hand trick. Tangent is square root of the top over square root of the bottom, so that's 1 at
45.
45 degrees. What's 45 degrees in radians?
Pi.
Okay. So now what's pi over 4 in quadrant 3? We know in quadrant 3 the top is 1 higher than the bottom. So your answer is 5 pi over 4. Any questions there? Then I am finished. I have a handout for you.